Hello and welcome to Mr. Tompkins Ed Tech. With 2 papers down and 1 to go, many of you have been asking about my predictions for topics likely to come up in paper 3. So I thought I'd make this quick series of videos compiled from questions covered in my practice papers and past paper walkthroughs. In each video I've taken one topic I think is a dead cert to come up on paper 3 and created a compilation of all the questions I've recorded on just that one topic. Question 20 starts off by describing an iterative process to find approximate solutions to x cubed plus 5x minus 8. It's got a flow diagram that you have to go around and work it out. And the question is asking us to use the iterative process to find a solution to 4 decimal places of x cubed plus 5x minus 8 is equal to 0, starting with the value of x equals 1. Which means we need to take the value x equals 1 and feed it into this process and see what happens. So let's do that then. I'm going to start by inputting the value of 1, so x is equal to 1. Work out the value of 2x cubed plus 8 all divided by 3x squared plus 5. Now that's easy, why x is 1. X cubed, 1 cubed is 1, times 2 is 2, plus 8 is 10. So that's 10 divided by 3x squared. 1 squared is 1, times 3 is 3, plus 5 is 8. So 10 over 8, which is 5 over 4, which is 1.25. 1.25. Is your answer to 4 decimal places the same as your value for x? No, it's not. So use your answer to 4 decimal places as your next value of x and start again. Okay, so I'm going to go back up to the top and I'm going to make 1.25 my input value. Right, I'm not going to be able to do this sum in my head this time, so it's time to reach for the calculator. Now this is going to be an iterative process, so I want to be able to feed my answer back into the calculator again and again without having to retype everything. So I'm going to start off by pressing the number 1 and then equals, so that will store the number 1 as the last calculated answer. And then I'm going to type in this long expression based on that answer. So I'm going to type in open bracket 2 times answer cubed plus 8 close bracket divide by open bracket 3 times answer squared plus 5 close bracket. Oh no, pressed the wrong key. Close bracket. Now when I press equals, it will feed in the answer 1 because that was my last calculated value, and it should spit out the 1.25 that we just calculated. There it goes, 1.25 or 5/4. So that was the result after going around once. Now if I press equals again now, it will feed in that 5/4 or 1.25 back into the iterative function, and it should give us the answer that we get the next time round, which is 381 over 310, which is a decimal number, is 1.229. We need to do these to 4 decimal places, don't we? So let's start that one. Okay, so let's write this down as a table. So the first one was 1. Let's rewrite that. The first solution was 1, and then we had 1.25, and now we've got 1.2290. Okay? Right, so now we need to feed that answer back in again. I just need to press the equal sign, equal key again, and it will feed that next number back in. Now I've got 1.2289 Is my answer to 4 decimal places the same? No, it's still different, so I'm going to press equal again. And I've got 1.2289 again. So now it is the same. These two were the same on my last go. So I've kind of reached the end point. This is my approximate solution to the equation, 1.2289. So my answer is 1.2289. Okay, by substituting your answer to part A into x cubed plus 5x minus 8, comment on the accuracy of your solution. Okay, so basically now I'm going to have to put this horrendous value into this equation and calculate what we've got. So if x equals 1.2289, then x cubed plus 5x minus 8 is going to be 1.2289 cubed plus 5 lots of 1.2289 minus 8. Let's type that into the calculator. 1.2289 cubed plus 5 lots of 1.2289. Okay, that comes out to be 0.0003789. Very small number. Okay, so this answer is very close to 0, which would mean that our answer is fairly accurate then, doesn't it? So close to 0, so approximation is accurate, or very accurate. Question 25. A sequence of numbers is formed by the iterative process an plus 1 is equal to an squared minus an. Describe the sequence of numbers when a1 equals 1 and show working to justify your answer. Okay, so in this iterative process, we get the next term of our sequence by taking the previous term, squaring it, and then subtracting off the previous term. So if a1 equals 1, then a2, my next term, is going to be my previous term, 1 squared, subtract 1. 1 squared is 1, take away 1 is 0. So then after that, my third term is going to be 0 squared, take away 0, which is 0. And then after that, I'm just going to get zeros. It's going to carry on repeating. So my sequence is going to go 1, 0, 0, 0, 0, off to infinity. Okay? So not the most interesting of sequences. I would describe it as 1 followed by zeros. Okay. Now, next, describe the sequence of numbers when a1 equals minus 1. Okay, so again, I'm going to start a1 equals minus 1. a2 is my previous value squared minus my previous value. Minus 1 squared is 1. Take away minus 1 would be plus 1. So that would give me 2. And a3 is going to then be 2 squared, take away 2. 2 squared is 4, take away 2 is 2. Oh, and then we're going to have another infinite loop then, aren't we? It's just going to go round and round again. So that is going to be minus 1 followed by a sequence of 2's. Another very boring sequence. So this one is a bit more interesting. Work out the value of a2 when a1 equals 1 minus root 2. Okay, well again, if a1 is equal to 1 minus root 2, then a2 is going to be my a1 value squared, subtract my a1 value. Okay, so I've got 1 minus root 2 squared. That's going to give me 1 squared minus root 2 squared, because the middle terms are oh no, it won't. Writing that as 1 minus root 2 times 1 minus root 2. And then doing FOIL on that bracket. 1 squared is 1. 1 times minus root 2 is minus root 2. Minus root 2 times 1 is minus root 2. Minus root 2 times minus root 2 is plus 2. And then I've got my minus 1 and minus root 2, which is plus root 2 on the end. Okay, so that plus root 2 is going to cancel with that one. So I've got 1 plus 2 minus 1, which gives me 2. And I've got my minus 2 there. So 2 minus root 2. That's my solution. Okay, we've got some iteration here then. So our next term in x, which is xn plus 1, is equal to 4 minus 2 over our last term in x, xn, all squared. So to work out an approximation solution to x equals 4 minus 2 over x squared. So we're going to start with x1 is equal to 1 and feed that into this expression and then work through it. I'm going to have to keep going until our answer settles down into a kind of a consistent answer. Okay, so we know that x1 is equal to 1, so then x2, our next term, is going to be 4 subtract 2 lots of x1, 1 squared. So 1 squared is 1, 2 divided by 1 is 2, and 4 subtract 2 is 2, so x2 is equal to 2. So then we just keep going. So what's x3? x3 is going to be 4 minus 2 over 2 squared, our previous term squared. So 2 squared is 4, 2 over 4 is a half, 4 subtract a half is 3.5. So that's our x3 term. x4 we're going to get by, again, we're just going to keep subbing back in, 2 over 3.5. I'm going to use a calculator now, 3.5 squared. Now, actually, with clever use of our answer key on a calculator, we should be able to feed in this answer very quickly, so we don't have to keep typing it in over and over again. If I press 1 equals first off, that will store the number 1 as my last calculated answer. And then if I type in 4 subtract 2 divided by answer squared, that will take my last calculated value, which was 1, and feed it into this expression. So when I press equals, you can see I got the answer 2, which is what I calculated earlier. But the clever thing is now 2 is now the stored value. So if I just press the equal button again, it will feed 2 into that same expression and then recalculate it. So that gives me my 3.5. So to make this easier on myself, now all I have to keep doing is just press equals, and that will keep giving me the next one. So the next one is 3.84 to 2 decimal places. Let's just, actually I might write it to 3dp to start with so we can see if it's settling down. Okay, so then x5 is going to be 4 minus 2 lots of 3.837 all squared. But I just need to press the equal button. That gives me 3.864. So it's still not quite settled down. So x6 is going to be 4 minus 2 lots of 3.864 all squared, and that is equal to 3.866. So that's going to round up, isn't it? If I round it off to 2 decimal places, that's going to be 3.867. So it's still not quite settled down. Let's just do another one. X7 is 3.866 all squared. And you can see now that this time it kind of just settles down on 866 again. Okay, and if I keep pressing it a few more times, you can see that it just stays like that. Okay, so then rounding that off to 2 decimal places, my final answer is going to be 3.87. That's 3.87. Question 15. Work out an approximate solution to x cubed plus 3x minus 1 equals 0 using iteration. So xn plus 1, the next term in x is equal to 1 over xn squared, the last term in x squared, plus 3. And we start with xy is equal to 1. Okay, so with these iterative methods, we keep taking a value and resubstituting it back into the equation until the answer settles down and we get a solution. So x1 equals 1, so then x2 is going to be 1 over our x1 value squared plus 3. Okay, so 1 over 1 squared. 1 squared is 1 plus 3 is 1/4, isn't it? And then we keep doing that. We're going to feed 1/4 back into here to get x3. So x3 is going to be 1 over 1/4 squared plus 3. Now I can't, well, I could probably do that in my head still, but it's easier to do it with the calculator. Now, rather than typing these all in individually, we're going to use the answer key to refeed the answer straight back into the calculation. So if I just put in the number 1 and press equals, that will store the number 1 as the last calculated value, and I can use it using the answer key. And then my next calculation I'm going to do is going to be 1 divided by, then I can use my answer key, which will currently be 1 squared plus 3. And then if I press equals, it should give me my quarter like it did last time when I worked it out. So all I need to do now is press equals again, and it will feed my 0.25 back in the equation and give me the next answer, which is 0.32. I'm going to write these down to 3 decimal places, one more than they're asking me to, so I can see when it's settled down. So this is 0.327. Okay, and then if I want x4, I just need to press the equal button again. That gives me 0.322 to 3 decimal places. And again, x5, you can see it's beginning to settle down now, is 322 again. Okay, and if I press it again, you can see it stays at being 322, 322. So it's kind of settled down now. Every time I press equals, I'm just getting the same answer now. So rounding that off to 2 decimal places, my answer is. Check out my other predictive topics by clicking on the card appearing here. Also, you can check out my practice paper walkthroughs by clicking on the card here. Or you can even go through actual past papers by clicking on the card over there. Good luck in your exams, and I'll see you next time.